So, hello and welcome to Healthcare Innovation Podcast by Healthark Insights. And in this episode, we have with us Marty Gauvin, the CEO of Fertilis, which is building a groundbreaking medical technology, I would say, to democratize in vitro fertilization, IVF as we call it, to make it more precise, more accessible, more affordable, both for the patients and the practitioners. So welcome, Marty, to this podcast, and thank you for agreeing to speak to us.
Mukesh, great.
Let me start. Before we go to Fertilis, I would like to understand from you, because you've spent years in the industry, Marty, to really explain how does the IVF landscape look like in Australia, and how is it vis-a-vis the other parts of the world?
Yeah, sure. So, I mean, obviously, IVF is still a relatively new technology, and it came into existence in 1980. So that's when the first baby was born by IVF, and so we now have a situation where there's been millions of babies born through this technique. But one of the things we say, before I dive into the Australian situation specifically, one of the things that we say is that IVF is failing the infertile. And the reason for saying that is because we still have a situation where, while IVF is a miraculous technique in many ways, allowing people to have their own children, the success rate is still very low, is still stubbornly low. And when you combine that with a lack of access, you have a situation where there are nowhere near as many IVF babies being born as there are people who would like to have one.
Oh, okay.
So that's sort of the first step. Now, in Australia, we have one of the highest rates of IVF in the world. There are other countries such as Israel that have higher. There are other countries in the world that have a lot less. And interestingly, the US is one of those. So the US has quite a low rate of IVF compared to places like Europe and Japan, China, places like that. And the situation for IVF, though, in Australia, one of the reasons why we have such a high rate per unit of population is it is largely covered under our Medicare scheme. So it is largely funded by the government for a certain number of cycles. And so there's a certain amount of co-payment. It's not easy financially. It's still a financial stress. And obviously, when you combine that with the other stresses, the emotional stresses of the whole process, no one should ever suggest that IVF is easy, even if it was completely free. But we do have this sort of level of support, so its availability is much higher. But by way of comparison, the number of IVF babies born each year in Australia is similar to the number of IVF babies born each year in the US, while the US is obviously a much larger country.
Okay. So if we were to put this in terms of statistics, what would they look like? Let's say on an average per annum, the number of
so about 80,000 babies are born each year through IVF in Australia, and as I say, a similar number in the US. But what that comes from is it comes from a number of cycles that's between 250 and 300,000.
Oh, okay. That's huge.
And so no, actually, let me get my maths right here. So it's actually, it's north of 300,000, between 300,000 and 350,000 cycles per year to produce 83,000 babies. So this is what I'm talking about. You've got a situation where the chances of success are still quite low, and those chances of success also vary with age. So for women who are in their 20s and early 30s, it's about maybe a 30% chance of having a baby through a single IVF process end to end, whereas it falls quite drastically as women get older. And of course, with the age of child rearing now being so much older, particularly in developed countries, you've got a situation where that's really impacting on the fertility rates of countries and resulting in this situation where we now have more than half the countries in the world I think it's nearly 2/3 now, have a non-replacement level of birth rate for their population.
All right, awesome. So now we've looked at the landscape of IVF, and now Fertilis it's trying to democratize the access, which is very essential for something like IVF. So and it says that it is going to be done through automation. So how does this work? I mean, a little more if you can elaborate on that.
Yeah, sure. So my so I'm the business guy and to some degree the engineer. My two co-founders are two of the best embryologists in the world. Jeremy Thompson and David Gardner, and David recently acknowledged as the embryologist of the year. So I guess that makes him number one embryologist.
Oh.
And what they say is that it's the environment the embryo is kept in that makes the biggest difference. But the main thing that causes damage to embryos, the main thing that leads to failures in these cycles is stress. And so if you think about what's happening in an IVF lab at the moment, and as I say, the process is miraculous, but it's quite labor intensive and quite a blunt instrument. The samples are taken, then they are fertilized, and one of the ways of fertilization is, you might have seen the video where they'll inject a single sperm into the egg. This is a process called ICSI, which our first device is focused on automating that. And then the embryo will be cultured. It will be sitting in an embryo for 5 days before it is then transferred back to the patient. Now, that sounds very simple. I've been able to describe it in less than a minute. But of course, when I say they spend 5 days culturing it, that means every few hours they're opening and closing the incubator. So the temperature that the embryo is experiencing is going up and down.
Okay.
If we ever want to shift an embryo from one kind of medium, the liquid that it sits in, to another, we pipette it up, we slurp it up, and then we drop it down into another drop. Which, of course, this is a pretty stressful thing as well.
Cool.
This process of ICSI that I talked about, when you're holding the egg and you're injecting a single sperm, you're actually sort of squishing the egg. You're sort of changing its shape and changing the way the internal structures are all working. So all of those stresses are the primary step that we want to take to improve the outcomes while also improving precision. So as I say, right now, the only way you can change from one medium to another is you slurp up the embryo and drop it into another drop. That's a stressful step, but it also means that you've got changing from one environment to another in an instant. Mm-hmm. Of course, that's not how things happen in the body. There's going to be a gradual change in the body. And so we have the means to be able to change that environment gradually and without opening the incubator, without causing that level of stress. And so these are the kinds of techniques that we've been able to apply to this problem. And as I say, it's really just around having some of the best embryologists in the world think about this from the process of going, let's just look at what we're doing and let's forget about it for a second that it's miraculous. Let's see what we could do to improve it. And so we see this, and this transforms the process in a couple of ways. Firstly, it improves the success rate, and that's obviously a fantastic thing.
Okay.
But we've also already been able to show that we can halve the time it takes to do IVF.
Oh, okay. Yeah. All right.
And so as soon as you can halve the time, then that starts the democratization process, because obviously time is money, and that's going to impact on the cost. But also it's very hard and complex to train an embryologist to do these processes.
Okay.
And so if you can get a skilled embryologist to get twice as many processes, twice as many treatments done in a day, then clearly that goes down the path of democratization.
I see.
But the other thing that we've found is that we can halve the time it takes to train the embryologists. And so it becomes a lot easier to bring on more staff, bring on more people to know how to do these complex and very precise processes. And so they're the steps: improve the success rate, improve the time taken, and improve the time taken to train.
Awesome. So this is amazing. Now there's a lot of buzz around, using AI into every MedTech that is out. So is Fertilis actually using AI at the moment, or do you have plans to incorporate, probably going forward, or how does it work out?
So we we use AI, but not in the way that anybody else does in IVF. And so this is an important step, I think, because the way that everybody's using AI in IVF is for selection.
Okay.
Essentially, you have a situation where you'll have a bunch of sperm, a bunch of eggs. So how are we going to pick what egg and what sperm we use? Let's use AI. Let's image them. Let's work out. Let's pick the best.
All right. Okay.
And then once we've fertilized a bunch of embryos, we're only going to implant one of those into the patient. So let's use AI to pick the best. Now, the problem with this focus on picking the best is it's one of the reasons why IVF is failing the infertile.
Okay.
Because, of course, if you went to a car yard and you were going to buy a new car, you're going to go and buy your first Tesla, then it would be kind of weird for them to say to you, well, just hang on a minute, we're just going to go up to find the best one for you.
Okay.
Because you would think, well, surely all of the Teslas meet spec. Otherwise, they'd never be on the lot.
True.
And so this idea of picking the best builds hope, but it's misleading. What if the best isn't good enough?
Yes, true.
And that's often the case. And so picking the best is something that only gives a very marginal improvement. Our focus is on improving all of them, so making better embryos. And so we're going to lift that standard up. We still can't accurately test for the perfect spec test, which would be, can this embryo go to full term and produce a live birth in that woman?
All right.
So that, of course, would be the perfect test. And that's one of the things we're aiming for. But what we can do is we can improve the embryos so we can lift the bar across all of the embryos that you've produced, rather than, as I say, this in many ways false hope of picking the best.
I see. Awesome. So, you spoke about increasing the success rate, and then you also spoke about how you can reduce the cycles. So I wanted to understand the economics of IVF and how Fertilis is contributing, just to understand the cost of IVF cycle per se, and as a ballpark, how many cycles does it typically take for a patient to kind of achieve success, and how is Fertilis in probably actual dollar value is really making a significant difference there.
Yeah, absolutely. So let me just pull up some notes here. So if we take current US pricing, so in the US, from a couple of sources, it's about $14,000 for a base stimulation. So stimulating the ovaries to produce some eggs, collecting those eggs, fertilize them using ICSI, which is this process that we've been working on, and then doing one fresh cycle. So essentially, the first egg, turning that into an embryo and getting that out. And then it costs about another $1,500 to preserve the remaining eggs. And then, but even then, you haven't actually got to a full cycle. So it then costs about another $4,500 for the medication. So these are the hormones that stimulate the ovaries. So round figures, you're going to be your pathway to your first, hopefully, pregnancy is going to cost you about $20K.
Okay.
Now, if I then did some modeling, and I said, okay, let's take a patient who's 30, and then look at the normal journey that a patient who's 30, and these are averages, and understand that the spread here is quite wide. So almost everyone won't be at the average, if you know what I mean.
Absolutely.
And then we'll take a patient B is 40. So for the 30-year-old, we get to 69,000.
Okay.
And for the 40-year-old, we get to 112,000 to have a baby. And of course, many of them won't have a baby. This is just the average.
Absolutely.
So in each case, you could be spending over 100K and still not have a baby.
Okay. All right. So I think that's where technology like Fertilis really play a great role. Now, world over, if you look at research, IVF demand is increasing.
Yes.
But at the same time, the success rates, as you have very rightly mentioned, are still low and prices still remain high. So how do we change the scenario here?
So from our perspective, if we look at it from the point of view of saying, let's first look at the supply. So from an economic standpoint, this is a supply constrained market. And the interesting thing about that is it's a supply constrained market everywhere in the world. So even countries like Belgium, which have a very high rate of IVF, some of the Scandinavian countries, Israel, you can still point to indicators that show that it's a supply constrained market, that this is not a situation where people who wish to get an IVF treatment can get access to it easily.
Okay.
And even in countries like Japan, where there's obviously a fertility crisis, and the government has now stepped in and is fully funding many treatments for any woman, they're still seeing only about 4 to 6% of their births are through IVF.
Okay.
And yet the demand, as I say, the demand is consistently higher. So you've got this supply of embryologists problem. And so we're addressing that in two ways, both by making the treatments take less time, and so an embryologist can do them quicker. And also as a side effect there, we're also making the treatments a lot less stressful to do. So by taking the automation steps forward, the things that the embryologist can focus on are much more straightforward. And this is the other reason why we're also making it faster to train an embryologist. And I'll give you the simplest example. The ICSI process, where you inject a single egg with a single sperm, is done with micromanipulators. So you're literally moving these eggs and sperm around at 1,000th of a millimeter kind of distance. Just ridiculously tiny, precise movements. The simplest way of explaining what we do is we make it so that you only need to use one micromanipulator instead of two. So straight away, you're essentially halving the effort, you're halving the stress.
Cool.
So some of these changes are quite simple and easy to understand. So this is one of the main ways that we've democratized the whole process. And then the other way we do it is by reducing the number of cycles it takes to have a child. We can reduce the number of cycles by 1 for every patient, whether they're 20 or whether they're 45. And so that reduces the cost of IVF, but also improves the availability, because there's then less rework, there's then less repeat cycles available. And so the capacity to then treat more new patients with the capacity of the industry that you have at any point in time increases. So we increase the capacity of the sector to do work. We improve the capacity of the sector to bring on more staff, and then we reduce the effort required to make a baby for any given patient.
Oh, wow. So Fertilis is currently only in Australia, or you have a global presence? And what's your future vision and mission, and how do you plan to, kind of increase the expanse and help more and more clinics, be more precise, more accessible and affordable when it comes to IVF?
So we are definitely a global company. We're based in Australia, but our devices, one of the things that's great about our devices, because they are so precise, they're also quite small. So one of our main devices, you can fit 8 million of them in a matchbox.
Okay.
So shipping and freight and so forth for our devices is not really a big problem. And there are 4,500 IVF clinics in the world. So for us to be able to engage that market from here or from any single location is pretty straightforward. It's not like you have to, talk to every fast food restaurant or every hospital or, whatever it might be. And so our first device will be going through the FDA process and will be available from second half of next year. So sort of October next year. And then we'll be bringing out more devices progressively after that. It'll be bringing on more and more of these features and treating more of or improving more of the treatments, more of the specific treatments that form parts of IVF. So we started our first human trials last week. Okay. They're going extremely well. And human trials in the US will be starting in with some of our partners in the next couple of months.
Wow, awesome. So at this point in time, you are at a trial stage and you have sort of a prototype ready, but eventually, probably next year, you plan to launch it all across once you have the FDA approval.
Yeah, exactly right.
Awesome.
The other thing that's not nice about these devices is we 3D print them. And so we use a very precise 3D printing technology, which means that we can print things that are very, very precise, that are extremely tiny. That also means that we can transform the way in which this sort of production takes place. So it's not like we have to build a huge stockpile or something like that, but we can actually print in multiple places in the world and get our production out to the people that need it. It also means that our ability to then bring on more products as we sort of kick off through the first one, transforming what we're doing and then building a pipeline of products to do this is made quite a bit easier.
Awesome. So it is clearly visible that there is a lot of opportunity when it comes to really using Fertilis technology. But what do you think could be the challenges in the use of it that probably you foresee?
So the one of the main things that we focus on is what we call adoptive comfort. Obviously, no matter how good this is for patients, it's up to the physicians, it's up to the embryologists, it's up to the people who are in the IVF clinics to decide whether they're going to use it. And so we have to produce devices that they're happy with and that work well in their hands. So that's very much been a focus of ours. And we have a scientific advisory board now of global leaders in the space to help us in those efforts. But that's absolutely a focus for us. For us to get to global coverage, obviously in the US, people talk about the FDA, and the FDA is one of the key regulators for us. Every country has a regulator.
Absolutely.
And so we have to go through
TGA.
dozens of regulatory processes to be able to get the full market coverage that we're after. And then the sort of the last step for us is how do we then get our progression of devices, our pipeline of devices into people's hands with the right kinds of support and so on and so forth. So one of the things that we're doing for that is we're looking at how we can use more of a digital technology platform. And this is one of the things that's potentially interesting to your audience. We really want to see whether we can get the right balance between the old way of delivering healthcare treatments to physicians, which is obviously lots of face-to-face time, lots of hand holding and helping, and which is of course very expensive and doesn't really facilitate getting products into the market that quickly. And so from our perspective, we're going, well, to what extent can we use more of an online engagement?
Okay.
And use the ways that other industries have built their whole kind of logistics capability to then be able to, combine that with a whole bunch of video training and these sorts of things to enhance our ability to be able to get things into the hands of physicians and delivered to patients without a lot of the complexity and in some ways old-fashioned ways of much of the supply chain.
Awesome. I think you've summed up the whole thing very, very nicely, Marty. It was an absolute pleasure speaking to you about Fertilis and the groundbreaking technology that you have developed to increase access for patients looking at IVF treatment. So thank you so much for speaking to us, and we wish you good luck with Fertilis, and we hope that it will help more and more people across the globe, seeking the treatment for IVF. Thank you so much, and you have a good day.
Thank you very much. Enjoyed it. Great talking to you. Bye-bye.
Bye.